me take a look. I'll upload something by the end of today, all right, regarding the tentative schedule, all right? I have to talk to the other instructors about tentative date, and I'll upload something by the end of today, inshallah, okay?
Okay, ma'am.
All right then. So, right, today we are going to talk about the very last topic of our ERD lectures. We're going to go into the enhanced entity relationship diagram, which is a model that was created by some things that were added to the ERD as we've studied so far. Now, these things that were added, these things should be relatable to you if you understand the concept of inheritance. Anyone here familiar with the idea of inheritance? How inheritance works in classes, perhaps?
Ma'am,
Um,
it's like ma'am. Shafet bolo.
বলো।
Okay.
Yes, it's like when a property is passed down to its descendants or something.
It's like
So,
a child object will copy all the properties from the parent object, like in case of Java class secretary.
That's right. In real life, how does inheritance work? In real life, you basically inherit something from your parent. You get something from your parents, right?
Yes,
Based on some sort of
Yes, ma'am.
written rule or written statement or something like that, a written document, a legal document. Based on a legal document, some things that are owned by your parents are passed on to you as their children, right? That's the idea basically, right? That's the idea. একই জিনিস, ঠিক আছে? একই জিনিস হয় যে প্যারেন্ট ক্লাস থাকে, সো প্যারেন্ট ক্লাস থেকে child class, if the child class inherits from the parent class, it has to be legalized, তাই না? First of all, যেরকম রিয়েল লাইফে আমাদের একটা রিয়েল ডকুমেন্ট থাকে যে ডকুমেন্টের বেসিসে আমরা ইনহেরিট করি, the legal document, ওরকম হচ্ছে গিয়ে same thing goes on, that you have to state that the child class is inheriting from the parent class, right? And then what happens is that based on that statement, because of that statement, প্যারেন্ট ক্লাসের যতগুলো অ্যাট্রিবিউটস আছে ওগুলো চাইল্ড ক্লাস ইনহেরিট করে। ইনহেরিট করাটার মানেটা কি? হোয়াট ডাজ ইট মিন টু ইনহেরিট? It means that every attribute that the parent class has is visible and usable for the child class, তাই না? That is, parent ক্লাসের যে অ্যাট্রিবিউটগুলো ওগুলো আমরা ধরে নিতে পারি they belong to the child class as well. Child class, yeah. So if you understand that idea, it's the same idea based off of which we have our enhanced entity relationship type, right? একই idea basis. Think about it. Let's consider a scenario such as this one here, the one that you can see. So here, let's say we've got three different categories. As you can see here, three different categories of employees. Hourly employees, salaried employees, contract consultants in an organization, all right? All of them are employees, by the way. Hourly employees are also employees, salaried employees are also employees, so are contract consultants, all right? However, hourly employees have the attributes employee number, employee name, address, date, hired, hourly rate. On the other hand, salaried employees, while they do have employee number, employee name, address, date, hired, just like the hourly employees, they have annual salary and stock option, two new attributes which hourly employees don't have. Also, hourly employees have an attribute called hourly rate, which salaried employees don't have. And then once again, contract consultants has some of the attributes which are common with hourly employees and salaried employees, and then you've got contract number and billing rate, which are not in common. So what do we do now? We have in our hand these data objects. We know that employee is a data object. Employee এমন একটা data object যার সম্পর্কে আমরা data maintain করতে চাচ্ছি, এটা আমরা জানি. We know that employee is such a data object. ঠিক আছে? এখন এমপ্লয়ি যদি একটা ডেটা অবজেক্ট হয় যার ডেটা আমি মেনটেন করবো, তার হচ্ছে গিয়ে অনেকগুলো ইনস্টেন্সেসও থাকবে. এমপ্লয়ি will have a lot of instances. Employee, as you can see, an employee has a set of characteristics, quite a lot of characteristics, all right? And an employee will obviously be related with a lot of other entities working for under a certain department, supervising other employees, so on. এরকম অনেক রিলেশনশিপস থাকবে. সো আমরা ধরে নিতে পারি এমপ্লয়ি আমাদের একটা এন্টিটি হবে, ঠিক আছে? এখন এই এমপ্লয়ি এন্টিটিটাতে আমাদের কি কি ক্যারেক্টারিস্টিক থাকতে পারে? Can anyone tell me? What are the attributes that we can list under the employee entity based off of this?
Number, name, address, and hired.
Okay. Then what about hourly rate, annual salary, stock option, contract number, billing rate? এগুলো কি আমরা we don't need to model this data at all?
It's sub entity basically. বানাতে হবে।
Why
Subtype.
though? Employer under আমি attributes গুলো রাখলে কি সমস্যা? What's the problem?
This not every type of employee will have these exact
Yeah.
like attributes.
And what's wrong with that?
So if you want to have only
empty
one,
থেকে যাবে।
Again?
this empty পড়ে থাকবে.
So
Like
basically
not
what
all
you're
employees will have.
So basically what you're saying is that employee নামের যদি আমি একটা এন্টিটি বানাই আর তার মধ্যে যদি এই সবগুলো অ্যাট্রিবিউট আমরা রাখি, যে প্রথম চারটা অ্যাট্রিবিউট এমপ্লয়ি নাম্বার, এমপ্লয়ি নেম, অ্যাড্রেস, ডেট, হায়ার, যেগুলো কমন, প্লাস দ্য ইউনিক অ্যাট্রিবিউটস অ্যাজ ওয়েল, আওয়ারলি রেট রাখলাম, অ্যানুয়াল স্যালারি, স্টক অপশন, কন্ট্রাক্ট নাম্বার, বিলিং রেট, সবগুলো হচ্ছে এমপ্লয়ি আন্ডারে রাখলাম. So what you're telling me is that some employees will have values for some of the unique attributes and null for the others, and so on for some of the other employees as well. That is, যারা hourly employee তাদের জন্য hourly rate attribute একটা ভ্যালু থাকবে, but annual salary, stock option, contract number, billing rate এই ভ্যালুগুলো null থাকবে, তাই তো?
Yes, exactly.
Yes. So yes, you guys are on point. That is one of the problems that would be there in this sort of modeling if we were to create a single employee entity যেখানের মধ্যে আমরা সবগুলো attribute রেখে দিব. If you put all of the attributes in one single entity, that's one of the problems. And also it doesn't model the data close to how the data is actually processed or close to the nature of the data itself. আমি যদি একটা সিঙ্গল এন্টিটি এমপ্লয়ি রেখে দেই, তাহলে এর মাঝে যে আওয়ারলি এমপ্লয়ি, স্যালারিড এমপ্লয়িজ, কন্ট্রাক্ট কনসালটেন্টস আছে, এই ধরনের সাব ডিভিশন বা এই ধরনের সাব ক্যাটাগরিজ আছে, এটা তো আমরা জানবোই না. We won't know that at all. We want to keep the data closer to how the data is actually used as well. So there won't be any differentiation there. That's not actually how the data is naturally handled in the organization. So yeah, and most importantly, what you guys said, that some of the attributes will have null values for some of the employees, for sure. যারা hourly employees তাদের জন্য annual salary, stock option, contract number, billing rate null থাকবে. যারা salaried employees তাদের জন্য hourly rate, contract number, billing rate null থাকবে. যারা contract consultants তাদের জন্য hourly rate, annual salary, stock option null থাকবে. And we don't want a data model where we know by default there will be some null values. In some cases, null values could be unavoidable. এরকম হতেই পারে যে কোনো একটা এমপ্লয়ের কিছু ডেটা মিসিং, আমার null রাখতে হয়েছে, alright? Or কোন একটা এন্টিটি অথবা কোন একটা টেবিলে ডেটা এন্টার করার সময় I don't have some information, আমার null রাখতে হয়েছে. Or the data type doesn't match, so system automatically rejected the data that I tried to enter and null রেখে দিয়েছে. এরকম কিছু unavoidable null cases থাকতেই পারে. But to create a data model while keeping in mind যে by default কয়েকটা attribute null থাকবে, that is a bad design decision, alright? কিছু ক্ষেত্রে মানে null হতেই পারে, unavoidable কিছু কেসে null চলে আসতে পারে, হতে পারে, but আমি যদি ডিজাইনটা করি এটা মাথায় রেখে যে আমার নাল থাকবেই, I know that beforehand যে এখানে নাল থাকবেই, আর আমি তারপরে ওই ডিজাইনটা করলাম, that's a bad design. I have to find a way so that I can avoid that scenario. And is there a way to avoid that scenario? Yes, there is, based on the idea of inheritance. Before we go there, why not create separate entities for these three? Employee নামের কোন entity আমার create করার দরকার নেই। আমাদের তো প্রবলেমটা কোথায়, যে কিছু অ্যাট্রিবিউটের ভ্যালু নাও থাকবে। Why not create an entity called hourly employees, an entity called salaried employees, an entity called contract consultants? Employee entityটা দরকারই নেই। Why can't we do that? If we do that, then that would solve your problem, right? The problem that you guys were pointing out.
Yes,
নাকি
ma'am.
নালের প্রবলেমটা তো সলভ হবে। নাল তো আর থাকছে না। আমি যদি আওয়ারলি এমপ্লয়ের একটা আলাদা এন্টিটি বানাই, আওয়ারলি এমপ্লয়ি এন্টিটিটা ক্রিয়েট করেছি শুধুমাত্র আওয়ারলি এমপ্লয়ীদেরকে মডেল করার জন্য। The hourly employee will model only the entity will model only the hourly employees. That is, hourly employee entity যতগুলো ইনস্টেন্স থাকবে তাদের সবারই আওয়ারলি রেট ভ্যালু থাকবে, ঠিক আছে? তাদের ওই আওয়ারলি এমপ্লয়ির মধ্যে তো আওয়ারলি রেট ছাড়া অন্য কোনো যে ইউনিক অ্যাট্রিবিউট গুলো আছে ওগুলো কোনো কিছু নেই। আওয়ারলি এমপ্লয়ি এন্টিটির মধ্যে আমি এই 5টা অ্যাট্রিবিউটই রাখবো। Do we understand that? We will create an hourly employee entity and we will keep only these 5 attributes there. Then we will create a salaried employee entity and we will keep only these 6 attributes there. Similarly, contract consultant আলাদা একটা এন্টিটি হবে, সেখানেও আমি এই 6টা অ্যাট্রিবিউট, শুধুমাত্র এই 6টা অ্যাট্রিবিউট কন্ট্রাক্ট কনসালটেন্টের আন্ডারে যারা আছে, এমপ্লয়ি নাম্বার, এমপ্লয়ি নেম, অ্যাড্রেস, ডেট, হায়ার, contract number and billing rate, only these 6 attributes will be there, none of the others. তাহলে তো হচ্ছে গিয়ে কোনো ইনস্টেন্সে null value থাকছে না। That was the problem, right? The null value. None of the instances would have null values anymore. At least by design it won't. That would solve your problem, won't it?
It would, but for
But?
example, if I want to search an employee, I will have to search 3 separate tables for them. That is one example, but basically like extra work to access these things, I guess.
And আমাদের যে separate methods লেখা লাগবে সবগুলোর জন্য, we can't just have a single method, update a single method in the employee class.
Methods come later. Writing methods, you do that after you extract the data or fetch the data from the database. Database থেকে data fetch করার পরে methods এর উপর লিখতে হবে। Database থেকে তিনটা combine করে আমি data নিতে পারছি। You will see there are SQL techniques like join operations and so on, যেখানে I can join multiple tables together and get the data. That comes later. Let's talk about the database operations, all right? So what I just said, when you guys are going along the right direction though, let's say for example, if I want information on a certain employee, all right, and I don't know whether it's an hourly employee or a salaried employee or contract consultant, আমি জানি না, ঠিক আছে? আমি জাস্ট জানি সে একজন এমপ্লয়ি। তো আমার সার্চ করতে হলে আমার কি করতে হবে? সবার মধ্যে সার্চ করতে হবে, তাই না? আর যদি সবার মধ্যে সার্চ করতে চাই, তখন somehow I have to find a way to extract data from all these 3 tables by joining them together. তিনটা টেবিলের ডেটা এক জায়গায় নিয়ে আসতে হবে বেসিক্যালি, তাই তো? তিনটা টেবিলের ডেটা আমার নিয়ে এক্সট্রাক্ট করে নিয়ে এসে, ফেচ করে নিয়ে এসে এক জায়গায় আনতে হবে, বিকজ hourly employees এর ডেটা একটা আলাদা টেবিল if it's a separate entity, salaried employees এর ডেটা আলাদা টেবিল if it's a separate entity, contract consultants আলাদা টেবিল if it's a separate entity. I have to combine them together. First of all, fetch the data from these 3 separate tables. তিনটা আলাদা আলাদা টেবিল থেকে I have to first fetch the data. এটা এনে আমার কম্বাইন করতে হবে, কম্বাইন করে ওখানে গিয়ে আমার এমপ্লয়ি নাম্বার অর এমপ্লয়ি নেম দিয়ে সার্চ করতে হবে which employee is it that I'm looking for, তাই না? Or what you could do is look for the employee number or employee name for in each of these 3 tables individually, right? Either way, it is possible. It's possible to do it. It's not that it's not possible at all যে এমপ্লয়িকে আমি সার্চ করব এই তিনটা টেবিল। It's possible definitely. আমি আলাদা আলাদা তিনটা টেবিলে সার্চ করলাম, অথরিটি টেবিলের ডেটা নিয়ে এসে আমি এক জায়গায় কম্বাইন করে দিলাম, ওখানে মধ্যে আমি সার্চ করলাম, করতেই পারি। But
Space and time complexity.
Time complexity, those 2 or 3 extra steps that you're going to take, that will cost you time, no? What if we have a way to avoid that? Why not take that? Extra যে দুটা তিনটা স্টেপ আমার নিতে হচ্ছে, প্রসেস করতে হচ্ছে ডেটাগুলো, why am I having to do that? এই জিনিসটা আমার কেন করতে হচ্ছে, এই এক্সট্রা কয়েকটা স্টেপ কেন নিতে হচ্ছে? বিকজ যদি আমরা এই তিনটা ডেটা অবজেক্টের জন্য আলাদা আলাদা এন্টিটি ক্রিয়েট করি উইথাউট এনি এমপ্লয় এন্টিটি এট অল, তাহলে আমি কি করছি? এই চারটা অ্যাট্রিবিউট, এমপ্লয় নাম্বার, এমপ্লয় নেম, অ্যাড্রেস, ডেট হায়ার্ড, the 4 attributes which are common among these 3 data objects, we are enforcing a repetition of these attributes or duplication of these attributes. এই অ্যাট্রিবিউট চারটা তো কমন, বাট এই চারটা অ্যাট্রিবিউট আমি রিপিট করছি তিনটা এন্টিটিতে বারবার, ঠিক আছে? So because of this, actually, because these 4 attributes are common but still we are repeating them across these 3 entities, আর আমরা আলাদা করে দিচ্ছি, এই চারটা অ্যাট্রিবিউট কমন হওয়া সত্ত্বেও আমরা আলাদা করে দিচ্ছি, we are separating these or we are distributing these 4 attributes among each of these entities. If we do that, what's going to happen is ওই যে যেটা বললাম যে let's say if I want to search an employee by an employee number or an employee name, what do I have to do? I have to go through each of these 3 entities separately, which is inefficient. All right. So in that case, our best option is what? Have both. Have both an employee entity and all these 3 entities as well. Employee entity ও থাকবে, hourly employee entity ও থাকবে, salaried employee entity ও থাকবে, contract consultant ও থাকবে, 4টা entity থাকবে. However, we'll have a parent entity. Parent class যেরকম থাকে, একটা parent entity থাকবে. What will be our parent entity? The employee entity will be our parent entity. All right? Employee will be our parent entity, and the 4 common attributes. The 4 common attributes: employee number, employee name, address, date hired. যে চারটা attribute তিনোটা data object এ আছে. The 4 common attributes, we will put them in the employee parent type.
So duplication হবে না না?
Duplication as in attribute গুলো duplicate করছে না, value কিন্তু duplicated হবেই না, মানে even if you were to create separate entities for these 3, কোনো employee entity, কোনো employee super type বা এরকম কোনো কিছুই নেই, just hourly employee, salaried employee, contract consultant entity create করলাম, আর সবগুলোর মধ্যে এই সবগুলো অ্যাট্রিবিউটই থাকবে। hourly employee মধ্যে এই যে 5টা অ্যাট্রিবিউট থাকবে, salaried employee তে এই 6টা অ্যাট্রিবিউটই থাকবে, contract consultant এও এই 6টা অ্যাট্রিবিউট থাকবে, ঠিক আছে? Even if you do that, value কিন্তু duplicate হবে না,
না ভ্যালু হবে না।
the value না, but the fact that এই অ্যাট্রিবিউট গুলো কমন, but আমরা তিনটার মধ্যে বারবার রিপিট করছি এই অ্যাট্রিবিউট, because of that, what's happening? The problem is where? The main problem is that যখন আমি একটা employee number দিয়ে সার্চ করতে যাব, and I don't know whether it's an hourly employee or salaried employee or contract consultant, employee number দিয়ে সার্চ করতে যাব, because employee number হচ্ছে গিয়ে তিনটার মধ্যে আলাদা করে দিয়ে দিয়েছি, either I have to search the employee number separately in these 3 tables, or তিনটা টেবিলের ডেটা একসাথে নিয়ে এসে আমার জয়েন করে ওখানে সার্চ করতে হবে। whichever way we go, আমার তো ওই যে এক্সট্রা কয়েকটা স্টেপ নিতে হচ্ছে প্রসেসিং এর ক্ষেত্রে, I am having to increase the number of steps that I have to take. So the amount of time that will take will also increase. That's inefficient. Because we have a better option, better method. What is that? Place the common attributes in a parent type, place the unique attributes in the individual child types. All right? A parent type টাকে হচ্ছে কি আমরা super type বলছি, আর child গুলোকে হচ্ছে কি আমরা subtype বলছি. The super type is the employee. And in employee, the super type, I will place the common attributes. The attribute গুলো a hourly employee, salaried employee, consultant, all 3 of them are supposed to have these attributes. ওই চারটা attribute আমি super type এর মধ্যে রাখবো। And the unique attributes কি ছিল? Hourly employee had hourly rate, and only hourly employee had hourly rate, none of the others. Only hourly employee had hourly rate. So hourly rate, I will place it only in the hourly employee subtype. Salaried employee had two unique attributes as well, annual salary and stock option. I'll place them in the salaried employee subtype. Same goes for consultant. Contract number and billing rate, only unique to consultant, none of the others. Place them in the consultant subtype. Okay? So that is the best solution that we could think of. Yeah.
Ma'am, so here we don't have to assign any like foreign keys for the subtypes.
Do we concern ourselves with foreign keys when we're talking about ERDs at all?
I actually no
We talked a
idea.
little bit about foreign keys, yeah, but ERD to foreign key niye amra worried na. We're not concerned about foreign keys in ERD. ERD te amra foreign key niye chintai korbo. If you're talking about primary key or identifier, that's a separate thing. Are you talking about identifiers or primary keys?
Yeah,
Okay,
identifiers.
that's a separate thing. That's a separate thing. Don't get that mixed up, no matter what.
Okay.
All right.
So,
Let's
so
say, for
my
example, in
problem
the
was
Viva exam, just this one small mix-up, calling it a foreign key when you're trying to talk about an identifier or primary key, that really will end up with you getting 0. Okay? Don't get these things mixed up. But yeah, it's এখন mix up hote pare. This is new to you, but make sure that you get enough practice. This is for all of you guys. Make sure that you get enough practice done so that you don't get these things mixed up. Yeah, primary keys are missing. We'll get to that just a little bit later, just once we go over the basics. All right. So yeah, supertype, subtype. Whenever we have a scenario where some, basically, as you have seen here, there is a scenario where some attributes of a couple of data objects are common, but some of the other attributes are unique. In that case, you should think about supertype subtype relationship right away. For example, even in this scenario, if let's say, for example, you're modeling university data and you're modeling data for both undergraduate students and graduate students, right? And student is an entity type in the university. So graduate students and undergraduate students obviously will have some attributes in common, like student ID, name, and the basics. But some of the other attributes might be unique for a graduate student as well as an undergraduate student. So what do we do there? Whenever you see a situation like that, this or the employee situation or anything like that, কিছু attribute common or কিছু attribute unique. What will we do? We will create a parent entity type, which we are calling the supertype, a generic entity type. A generic entity type. We will create a generic entity type, which we are calling the supertype. So here in this example, for example, student will be the supertype, and we will keep the common attributes, all the common attributes in the supertype. And then we will create subtypes for those data objects which have some unique attributes amongst themselves or share unique relationships or have unique relationships. So subtype, the child will become the subtype. In this case, graduate student and undergraduate student, these are the two subtypes. So we will create a subcategory or subgroup or subtype, whatever you call it, for graduate student, and we will keep the unique attribute or the unique relationship of graduate student in that entity, separate from the others. And same goes for undergraduate student. Subtype, supertype. How we represent supertype, subtype. The notation. Let's talk about that. So all of them are still entities. Supertype entity is still an entity. Subtype entity is still an entity. So similarly, entity J notation, what I use for it's a rectangular box with sharp edges and attributes listed underneath the name of the entity, and the name of the entity will be in all caps. Entity name থাকবে all caps, attribute গুলো list করব underneath the name of the entity, and all of that will be placed within a rectangle with sharp edges. All right, we'll do that. And then, what about the subtypes as well? Same thing. But this is new, right? This here, this line coming out of the supertype connects to this circle here. All of these notations will have new things added to them as we explore the topic of supertype subtype. But for now, the basic notation, bear in mind that there'll be a line connecting the supertype entity with this small circle or connector, you could say connector, and then from this connector we will have individual lines protruding and connecting to every single one of the subtypes. This semicircle that you see, that one is not necessary. All right, semicircle notation data usually we don't use that at all. Just simply একটা line থেকে supertype থেকে এই connector connected হবে, this circle which will act as the connector, this circle, and then out of the circle comes lines connecting to the subtypes as well. As simple as that, so on and so forth. And then also relationship lines, just like before. আমরা যে আগে যে relationship লাইনগুলো দেখেছি with the cardinality symbols and so on, it will be exactly the same. একই জিনিস থাকবে, crow's foot use করো বা circle বা bar, whichever you use, all the notations that we have seen for relationship lines and the cardinalities, they are the same. However, relationships that are shared by all instances are connected to the supertype, and relationships which are unique to a specific subtype is connected to only that subtype. Obviously, just how একটা subtype unique attribute গুলো শুধুমাত্র ওই subtype এর আন্ডারে রাখা হবে. That's what you have seen, right? In case of employee, unique attributes are placed within the respective subtype, and only that one. Similarly, unique relationship যেগুলো subtype 1 এর যদি কোনো unique relationship থাকে, এটা শুধুমাত্র subtype 1 এর সাথে relationship লাইনটা connected থাকবে, right? This is actually not even the complete notation. This is just to give you the basic idea. You will see that we will add more things into these things as we talk about more ideas that we have within the category of EERD or supertype subtype. Now, so we do all of this based on the idea of attribute inheritance, all right? The idea of attribute inheritance is such that, which is clear to some of you guys, I'm sure already, if you're familiar with the idea of inheritance. So attribute inheritance, it means that every single attribute of the employee supertype is automatically inherited by each one of these subtypes. And here we come upon the discussion of the primary key. Why the subtypes don't have a primary key? Why doesn't hourly employee have a primary key? Why salaried employee or consultant doesn't have a primary key? Why not? Which one is the primary key in this entire image? Can anyone of you tell me that?
Employee number.
How do we know that? How do we know that?
Bold and one underline.
That's right. Bold and solid underline tells us that employee number is the primary key. But hourly employee, salaried employee, consultant, contract consultant, তাদের কোনো primary key নেই কেন? Because of attribute inheritance. Remember that the subtypes will automatically inherit everything from the supertype. Employee সবকিছু subtype গুলো automatically inherit করবে. So hourly employees, this specific data object automatically inherits all of these things from the employee, right? Salaried employee also inherits these things from the employee. That's why employee number, employee name, address, date hired, attribute গুলো, these attributes are not listed individually among these subtypes. Subtype গুলোর মধ্যে আলাদা করে আমরা list করিনি, because this whole subtype supertype idea is created based off of the property of attribute inheritance, where every single one of the subtype automatically inherit everything from the supertype, including the primary key. So the fact that we have denoted the primary key of the supertype automatically goes to say that hourly employee will inherit the primary key employee number from employee as well. So if you're asking why the subtypes do not have a primary key, the answer is that the subtypes actually do have a primary key. They do. They have a primary key. They have inherited the primary key from the supertype, okay? Because they inherit everything from the supertype, including all the attributes and the relationships that the supertype may have. Make sense so far, guys?
Yes.
Yes, ma'am.
All right, then. It will keep making more and more sense once we get closer to the physical implementation throughout the next steps of our data design phase. But for now, let's just stick to the topic of ERD. Okay, so when is it that we have to remind ourselves that there is an option to create a supertype subtype relationship, like we've already discussed? Whenever you see that some attributes or some relationships are common, while some of the other attributes are not common or are unique for some of the other entity types. All right. So in that case, that should be an indication for you that okay, there is a possibility, there is a room for here for creating supertype subtype relationships here. For example, take a look at this specific case. So here we've got a patient entity, which is the supertype. No, patient is the supertype here, and the subtypes are outpatient and resident patient. So why do we have the supertype subtype situation? Why? Because resident patients, patients who are staying, let's say, at the hospital, it makes sense for them to be assigned a bed. They're staying in the hospital. It makes sense for them to be assigned a bed. It makes sense for them to have a date discharged. Outpatients, however, who are visiting the hospital to see a doctor maybe, but they don't stay in the hospital. If they don't stay in the hospital, they won't have a bed assigned to them, obviously. They won't have a date discharged. They will, however, have a check back date. Maybe they go back to the doctor with the reports or the test results and so on. And this check back date, on the other hand, is something that the resident patients will not have. Resident patients are residing within the hospital. The doctors will visit them and check back on their own. They don't have a date to check back. They don't have to revisit the hospital. They are in the hospital already. All patients are not going to be resident patient and outpatient at the same time, obviously. A patient who is a resident patient is not going to be an outpatient. A patient who is a resident patient will not have a check back date. A patient at the same time who's an outpatient will not have a bed assigned to them or a date discharged. So for example, such a scenario. However, all patients share some attributes in common. Patient ID, patient name, admit date. Also, the physician that they're assigned to or they're looking for. Right? The outpatients, maybe they have a specific physician that they go to in that hospital. The resident patient, maybe they're assigned a specific physician. However, regardless, all patients are assigned a specific physician. That is true for all patients. Outpatients, resident patients, both. So this is another scenario where some of the patient instances will have a check back date, but those instances will not have a date discharged and bed ID. And some of the other instances will have date discharged and bed ID, but they will not have a check back date. However, all instances of patient will have these three attributes in common and will have a specific physician assigned to them. So what do we do here? Supertype, subtype. Common attribute গুলো supertype এর আন্ডারে রাখবো, unique attribute গুলো subtype এর আন্ডারে রাখবো, as simple as that. Also, relationship, take a look at that. The relationship which is applicable for all instances is connected to the supertype. All patient instances are cared for by physician. So, প্রত্যেকটা individual patient instance এর একটা করে physician আছে. And every single physician maybe is caring for multiple patients. That is a single physician if you think about it. একজন physiciaনের কথা যদি চিন্তা করি, একজন physician multiple patient কে দেখছে maybe, all right? So it's a one-to-many relationship. Mandatory one to optional many relationship. Regardless of that, that is not our main focus here. The main point is that all patient instances will have this relationship, will share this relationship with a physician. প্রত্যেকটা পেশেন্টেরই একটা করে physician assign করা আছে. So that's why we will attach this relationship line with the supertype. Right? However, this, on the other hand, a bed, So a bed is not assigned to all patient instances. Outpatients will not be assigned a bed. They're visiting the hospital, they're not staying in the hospital. So this relationship between a bed and a resident patient is unique to the resident patient. So this relationship line only attached to this this subtype. This relationship line attached to the resident patient subtype and only that one, because it's not shared by the other instances under other categories. It's not applicable for all patient instances. It's only applicable for resident patient instances, right? That's a scenario where you create a supertype subtype relationship. Now, if we have a couple of entities in our hand, the processes or the techniques that we can apply to get to a supertype subtype situation, all right? Two techniques, we will look at two such techniques or two such processes that we can apply to get to a better data model or a better data design where we use supertype subtype model to the utmost efficiency. One will be generalization and the other will be specialization. First, let's talk about generalization. So we've got three entities here in our hands: car, truck, motorcycle. Do you see that some of the attributes are common among these three entities? Car, truck, motorcycle. What are the attributes that are common?
Price and engine displacement, vehicle name.
Vehicle ID, price, engine displacement, vehicle name. That's right. So these four attributes are common among these entities. So in that case, can we make just one single entity to represent all three of them? একটা এন্টিটি দিয়ে কি সবাইকে রিপ্রেজেন্ট করতে পারি? একটা সিঙ্গেল এন্টিটি দিয়ে সবাইকে রিপ্রেজেন্ট করতে পারি? Just a single entity represent all of them together. Will that be our solution?
Yes.
Yes? Is that so?
Yeah. Yes.
মিস পারা যাবে, বাট ওই যে ওই প্রবলেমগুলো অ্যারাইজ করবে।
নাল থাকবে, ওইগুলো থাকবে।
That's right. What about if we use a single entity? একটা single entity দিয়ে যদি সবগুলোকে রিপ্রেজেন্ট করি, just একটা entity দিয়ে সবগুলোকে রিপ্রেজেন্ট করলে, then where will I put number of passengers, capacity and cap type? সবগুলোকে একই জায়গায় রাখবো? In that case, what about instances of motorcycle? They won't have any value for number of passengers, capacity and cap type. Null থাকবে. What about instances of car? They won't have a value for capacity and cap type. এ দুটো value null থাকবে. So once again, we are going with a design যেখানে we know for sure that there will be null values, which is a bad design, all right? So what can we do? We have some common attributes and some unique attributes. Number of passengers, unique to who? Car. Truck and motorcycle does not have number of passengers. Capacity and cap type, unique to who? Truck. Car and motorcycle do not have capacity and cap type. So this is the exact scenario that we were talking about. Some attributes are in common, while some of the other attributes are not in common. Some of the other attributes are unique, right? So আমরা যেটা করব, simply যেহেতু অলরেডি আমাদের কাছে তিনটা এন্টিটি আছে, কার, ট্রাক, মোটরসাইকেল, তিনটা এন্টিটি যেহেতু অলরেডি আছে, এই তিনটা এন্টিটি থেকে আমরা যেটা করব, the process of generalization, what it tells us is just take the common attributes out. Generalization আমরা যেটা করি, common attribute গুলো নিয়ে এসে একটা generic entity type create করব. Here we don't have any generic entity type, তাই না? কার, ট্রাক, মোটরসাইকেল তিনটাই হচ্ছে গিয়ে individual আলাদা তিনটা entity আছে. Generic কোন entity type এখানে নাই. There is no generic entity type. In the process of generalization, what we do is, if there are entities which are specialized but share some common attributes, we simply take the common attributes out. Simply common attribute গুলো বের করে এনে একটা generic entity type এর আন্ডারে বসিয়ে দিব. The entities that were there already, ওগুলো থাকবে। car, truck, এগুলো থাকবে। We are not going to touch the entities, but the attributes inside, যে attribute গুলো আছে ভিতরে, common attribute যেগুলো, common attribute গুলোকে বের করে নিয়ে আসবো। কারের মধ্যে আছে টোটাল 5টা attribute। 5টা attribute এর মধ্যে 4টা attribute the 4 of the 5 attributes are in common with the other entities. এই চারটি অ্যাট্রিবিউটকে কার থেকে বের করে নিয়ে আসবো। সো কারের মধ্যে কি থাকবে? শুধুমাত্র নাম্বার অফ প্যাসেঞ্জার্স থেকে যাবে। We had 5 attributes to start with. 4 of the attributes are in common with the other entities. Take those out of car. বাকি থাকে শুধুমাত্র নাম্বার অফ প্যাসেঞ্জার্স। ট্রাকের থেকেও 4টা কমন অ্যাট্রিবিউট আমি বের করে আনবো। We had 6 attributes to start with, and among these 6, the first 4 attributes are in common with the other entities. We'll take those out, and truck will be left with only capacity and cap type. All right. আর এই যে কমন অ্যাট্রিবিউট গুলোকে যে বের করে আনছি, we're taking out these common attributes. Where will we place them? In a generic entity type vehicle. All right. All 3 data objects share these 4 common attributes, so we'll create a generic entity type vehicle and place the common attributes there. As simple as that. Supertype subtype relationship create. Okay, make sense, guys?
Yes.
Yes, miss.
In that case, tell me, what did we do with motorcycle? Motorcycle naked in this transformation. Where is motorcycle?
Motorcycle is a vehicle.
That's right. Motorcycle is a vehicle, and motorcycle is also already being represented by vehicle. Motorcycle এর কি কোনো unique attribute আছে? Specialized attribute আছে? No. That should be another indication for you about how we create supertype subtype entities. When a child does not have any specialized attributes or specialized relationships or a unique attribute or a unique relationship, then you do not create a subtype for that child at all. Motorcycle এর নিজস্ব আলাদা unique কোনো attribute বা unique relationship নেই। So motorcycle এর জন্য আমার আলাদা subtype create করার দরকারই নেই। Motorcycle is already being represented by vehicle. Why do we need car and truck separately? Car and truck এর আলাদা আলাদা subtype কেন লাগছে? Because they have unique attributes or specialized attributes of their own. Motorcycle does not have that. That's why we did not create a subtype for motorcycle. It's already being represented by vehicle. Keep that in mind always. Some people make a mistake here. Even if a certain entity type doesn't have any specialized attribute, they create a subtype for that. That's wrong. Okay. Now, what is the process of specialization? The opposite of generalization. Simply the opposite of generalization. If you have in your hands an entity, like this one here, part, where some attributes will always have a value, while some of the other attributes will be null for some instances based on what type of instance that is. In that case, specialization comes. যেখানে দেখো 3টা আলাদা data object ছিল, তিনটার মধ্যে আমার attribute গুলো ভাগ করে দেয়া আছে। এখানে we have only one data object part. However, part এর ভিতরে if you notice, you will see that some attribute makes sense for some types of part, but not for all. All right. Part number, description, quantity on hand, location, fine. সব part এ থাকবে। What is routing number? Routing number is a number that we assign when a part is manufactured right at the start. একটা ফ্যাক্টরিতে একটা পার্ট যখন ম্যানুফ্যাকচার করা হয়, ওই পার্টটাকে একটা নাম্বার অ্যাসাইন করা হয়, ঠিক আছে, রুটিন নাম্বার, রাইট? And then think about that. If a part is manufactured within the factory for which you're creating the data model, if the part is already manufactured within the factory, will that part be supplied? আমি একটা certain part রুটিন নাম্বার 1 2 3 4 দিয়ে দিয়েছি, ম্যানুফ্যাকচার করেছি, ঠিক আছে, রুটিন নাম্বার 1 2 3 4 এই পার্টটা আমি ম্যানুফ্যাকচার করেছি, ভালো কথা। এই পার্টটা অলরেডি I have manufactured, I have it in my hands. Will that part also have a supplier ID and unit price value? I'm manufacturing it, I have manufactured it. Why will I have a supplier ID and unit price for it? একটা part, a single part instance, I'm talking about a single part instance. All right. Let's say, for example, a bike suspension. একটা suspension একটা specific part. one instance has been manufactured within the factory. If I have manufactured this specific instance, I'm not going to have a supplier ID for it because কোন একটা part, let's say suspensionary আর এরকমই একটা part অন্য আরেকটা instance হচ্ছে গিয়ে I got it supplied by a supplier. What does that mean? If I got it supplied by a supplier, then I haven't manufactured it. So basically a part instance cannot be manufactured and supplied at the same time, can it? If a part is supplied by a supplier, it hasn't been manufactured. The fact that it has been supplied, কোন একটা part supplier দ্বারা পেয়েছি, তার মানে কি? এটা manufacture করা হয়নি. It hasn't been manufactured. On the other hand, if a specific part instance has been manufactured, it means that the factory itself has created it. It wasn't supplied by any supplier or anything like that. So basically, those parts which were manufactured within the factory will have a value for routing number, while the parts which are supplied by a supplier will have supplier ID and unit price. However, manufactured parts will not have any value for supplier ID and unit price, and supplied parts will not have any value for routing number. So when we have such a situation in our hands where some of the attributes in a certain data object will have values for some specialized instances, not for all, in that case, we apply the technique of specialization. What we do is, যে অ্যাট্রিবিউটগুলো ঝামেলাটা ক্রিয়েট করছে ওই অ্যাট্রিবিউটগুলোকে আমি এন্টিটিটা থেকে বের করে আনি। The opposite of generalization, basically. The attributes which are specialized, in this case, routing number and supplier composite multi-valued attribute. Supplier নামের যে composite multi-valued attribute আছে and routing number যে attribute আছে, এই দুটো attribute এর জন্যই তো ঝামেলাটা হচ্ছে, তাই না? এই দুটো attribute হচ্ছে কি দেখা যাচ্ছে specialized for some instances, not for all. So we will take these attributes outside of part. Part থেকে attribute গুলোকে বের করে নিয়ে আসবো. This is what then part looks like. If you take routing number and supplier out of it, this is what part looks like. Then place routing number under a specialized entity. A specialized entity, which is our manufactured part subtype. So routing number is for only the instances of manufactured part, not for all. And supplier will put that under purchase part. Since it's a composite multi-valued attribute, as you will remember from the last session, multi-valued composite attribute ক্ষেত্রে, we can do something like this. So supplier ID is for a supplier, right? And the unit price is the price that the supplier is charging for the part it's supplying to the factory. So purchase part, a certain purchase part, the supplier is supplying the part and at what unit price. Right? Okay, so specialization, another technique that we can apply for creating supertype subtype relationships, as you can see here. Any questions so far? Okay, good. And let's move on. So just how we have cardinality constraints on relationships, in case of subtype supertype relationships as well, we have some constraints, specific constraints for the supertype subtype relationship. We call them the completeness constraint, and another constraint that we will discuss is the disjointness constraint after the completeness constraint. So two types of constraints. একটা হচ্ছে completeness constraint, একটা হচ্ছে disjointness constraint. Let's talk about the completeness constraint first. Completeness constraint addresses whether a certain instance can exist without belonging to any of the subtypes or not. All right? So under completeness constraint, you can either follow the total specialization rule or partial specialization rule. Remember, every single supertype subtype relationship must follow one of these rules. every single supertype subtype relation must follow one of these rules, either total specialization rule or partial specialization rule. Completeness constraint এটাই স্পেসিফাই করে, completeness constraint এটাই স্পেসিফাই করে যে আমার subtype supertype relationshipটা whether it's going to follow the total specialization rule or the partial specialization rule. Which one it's going to follow? One of these two it must follow. যেটা এখন পর্যন্ত আমরা ডিনোট করিনি actually. So far we haven't denoted anything like that, but one of these two must be followed. So what is the total specialization rule and what is the partial specialization rule? The total specialization rule specifies that an instance of the supertype must belong to at least one of the subtypes. That is, an instance cannot exist without either being an outpatient or a resident patient. Here, a patient instance cannot exist without being either an outpatient or a resident patient. That is, এমন কোনো patient instance থাকতে পারবে না যে হচ্ছে গিয়ে neither an outpatient nor a resident patient. Right? There cannot be any such patient instances, which is neither outpatient nor resident patient. Every single patient instance is either an outpatient or a resident patient. One of the two. All right? You cannot have any patient instance who is neither. That is what is specified by the total specialization. Yes.
You defined it. Could you please repeat it? An instance of a thing cannot exist without
A patient. There cannot be any patient basically. If we apply the total specialization rule, it means that আমার যে ডেটাবেসে পরে গিয়ে আমি পেশেন্ট নামে একটা টেবিল ক্রিয়েট করব না, ওই পেশেন্ট টেবিলে এমন কোনো পেশেন্ট ইনস্টেন্স আর এমন কোনো পেশেন্টের রো থাকতে পারবে না who is neither an outpatient nor a resident patient. That
Yes,
is,
ma'am.
if that
I
instance
was
is there in the
asking
patient
for the
table.
definition.
So Miss Patient is an abstract class, right?
Yes, very close to that idea. That's right. Very close to the idea of an abstract class. Patient instance must be either at least an outpatient or a resident patient. If there is a patient who is not an outpatient nor a resident patient, we cannot have that patient in our database at all. Database এরকম কোন patient রাখা যাবে না। Basically বুঝাচ্ছে যে patient table এমন কোন যদি if there is a row in the patient table, that row must be there either in this table or in this table. As simple as that. There cannot be any patient who is neither outpatient or resident patient. At least one of the two হতেই হবে. And how do we notify? How do we use the notation for that? In our ERD, we will simply use a double line to the connector. Supertype থেকে যে connector-এ আমি একটা double line আছে. See that, notice that. Right? Notice that in the previous cases so far, it was always a single line that we've used so far because we haven't talked about this constraint so far. So what we will do is we will use a double line from the supertype to the connector. That is our notation, which specifies that this supertype subtype relationship is following the total specialization rule. And remember, it must follow one of these rules, either total specialization or partial specialization rule, যে কোনো একটা ফলো করবে। যদি আমি এই ডাবল লাইনটা দিয়ে দিই, তাহলে বলছে যে এই সুপারটাইপ সাবটাইপ রিলেশনশিপটা টোটাল স্পেশালাইজেশন রুল ফলো করছে। তার মানে হচ্ছে গিয়ে আমি বেসিক্যালি এমন কোনো পেশেন্ট ইনস্টেন্স ক্রিয়েটই করতে পারবো না যে হচ্ছে গিয়ে neither outpatient nor resident patient. It has to, the patient instance has to be at least either an outpatient or a resident patient. Okay. Clear, everyone?
Yes, miss.
Yes, miss.
Okay, cool. Let's move on then. What about the other rule then? Partial specialization. It's simply the opposite. It basically goes to say that supertype instance can exist who is neither, which belongs to neither one of the subtypes, as you can see here. A supertype instance, such a supertype instance can exist which belongs to neither one of the subtypes. All right. Here, for example, Can we apply, first tell me, can we apply total specialization rule here? If the decision is up to you.
No, because of the
Why can we not do that?
motorcycle.
Because of
The
the
motorcycle
motorcycle.
can
That's right. Exactly. এখানে যদি আমি total specialization rule apply করতাম, double line যদি দিতাম এখানে, if we were to apply a double line here, what would it mean? There cannot be any vehicle instance who is neither a car nor a truck. Then what about motorcycles? Motorcycles cannot exist then, can they? So a specific case আমরা total specialization rule apply করতেই পারবো না, right? So you have to be able to differentiate that. Differentiate between that. That in this case, it does not make sense at all to apply the total specialization rule, because in that case you will not be able to model the data of motorcycles. Okay, so for this example, we have to apply the partial specialization rule, which specifies that such vehicle instances can exist which are neither car nor truck. For example, motorcycles. They're neither car nor truck, but they are vehicles nonetheless. So vehicle instances এরকম, that is আমার vehicle table পরে গিয়ে আমার vehicle table এমন কোন রো থাকতেই পারে যে হচ্ছে গিয়ে কার টেবিল ট্রাক টেবিল দুটার একটাতেও এক্সিস্ট করে না। In this case, the patient instance must exist in outpatient and resident patient tables, either outpatient or resident patient table as well, right? Either one of those, at least one of those. But here, such a row can exist in the vehicle table which does not belong to car or truck, any one of those tables. Okay, that's partial specialization rule. And partial specialization rule, the notation that we use for that is the one that we've seen so far. Simply a single line connected to the circle, a single line. It may look like that it's being bold. It's not, you don't have to worry about that. It's just a single line. একটা ক্ষেত্রে হচ্ছে কি single line, একটা ক্ষেত্রে হচ্ছে কি double line, right? So here, for example, here as well. This one, this example, we could say that it's following the partial specialization if you use a single line. Here as well, if it's a single line, even if it's the same example where we use the total specialization, যদি একটা single line থাকে এরকম, তাহলে কিন্তু আমরা ধরে নিব partial specialization. So in the ERD, when you draw the ERD for the exam or the project, so you have to specify these things clearly. যে আগে থেকে ফার্স্ট অফ অল ডিসাইড করতে হবে যে কোন রুলটা এখানে অ্যাপ্লিকেবল, টোটাল স্পেশালাইজেশন রুল না পার্শিয়াল স্পেশালাইজেশন। ইফ ইউ থিঙ্ক দ্যাট টোটাল স্পেশালাইজেশন রুল ইজ দ্য ওয়ান দ্যাট ইউ ওয়ান্ট টু গো ফর, হাউএভার ইআরডি তে যদি এরকম সিঙ্গেল লাইন ড্র করো, we will assume that you are trying to mean the partial specialization. So be very careful here in the exam. A simple thing like this, whether you're using a single line or a double line. Here, for example, even if it's the same example, just because it's a single line, it means that it's partial specialization. Single line, partial specialization. Single line, partial specialization. If it's a double line, only then we take it to mean that it's total specialization. Right? The disjointness constraint. The disjointness constraint talks about whether an instance can belong to multiple subtypes at the same time. So, এই টপিকটা নিয়ে কথা বলি। So, a patient instance, in order to exist, based on the total specialization rule, a patient instance must either be an outpatient or a resident patient. ভালো কথা, fine. The question is, can it be both? Total specialization rule কি স্পেসিফাই করে? Patient instance either outpatient হতে হবে or resident patient হতে হবে. But can it be both?
An outpatient can become a resident patient.
But তখন ট্রান্সফার হবে, it's still either or, একসাথে দুইটা হতে পারে।
My question is, can a patient simultaneously at the same time be an outpatient or a resident patient at the same time?
No.
No, miss.
Why is that?
It just doesn't make sense logically.
Look at this ERD. Take a look at this ERD. In terms of this ERD, tell me, why is that? Why can an outpatient and resident patient Why cannot they? Why cannot a patient instance be both at the same time?
Yes, either an outpatient or a resident patient. So দুটো তো একসাথে হওয়ার কথা না simultaneously.
Probably because if resident patient হলে তো তার একটা bed must লাগবে. So an outpatient cannot have a bed. So he
Will not
the
have a
person,
bed. Exactly.
Yeah.
So based off of these unique attributes and the relationships, ঠিক আছে? Total specialization rule কিন্তু whether the subtypes, a patient instance, whether a patient instance can belong to both the subtypes or not. এটা নিয়ে total specialization rule কিন্তু কিছু বলে না। Total specialization rule শুধুমাত্র আমাদেরকে এতটুকুই বলে যে a patient instance must be either an outpatient or a resident patient. এমন কোনো patient instance থাকতে পারবে না who is neither an outpatient nor a resident patient. Total specialization rule just এতটুকুই বলে দেয় যে there cannot be any patient instance, there cannot be any such patient instance who is neither an outpatient nor a resident patient. At least one হতেই হবে. But it doesn't state whether it can be both or not. Simultaneously, a patient instance can be both an outpatient and a resident patient or not. এটা নিয়ে total specialization rule কোনো কিছুই বলে না। The disjoint rule talks about that. The disjoint rule addresses that. Whether a patient instance can be an outpatient and a resident patient both at the same time. We haven't addressed that here at all. Disjointness constraint কোনো কিছুই আমরা এখানে specify করিনি because we hadn't talked about that concept yet. But now, if we talk about this example here, it's obvious based on our discussion, a patient instance cannot be an outpatient and a resident patient at the same time. It doesn't make sense. But the total specialization rule doesn't specify that. Total specialization rule কিন্তু এটা নিয়ে কোনো কথা বলে না। এটার জন্য হচ্ছে কি আমাদের disjointness constraint use করতে হবে। To specify that, we have to use the disjointness constraint. So when we have a scenario in our hand that the instance of the supertype cannot belong to more than one subtypes at the same time, we use the disjoint rule, or we apply the disjoint rule denoted by this D here. This D represents the fact that this specific supertype subtype relationship is following the disjoint rule. A patient instance will have to be either an outpatient or a resident patient, fine, but cannot be both at the same time. The total specialization rule, the double line that you see here, the total specialization rule tells us that a patient instance must be either an outpatient or a resident patient. And the disjoint rule, represented by this D inside the circle, the disjoint rule tells us that a patient instance cannot be both outpatient and resident patient at the same time. And that's right, they cannot be. Because resident patients will not have a check back date and outpatients will not have a bed assigned to them. They're not staying in the hospital. They don't have a bed assigned to them. And they won't have a date discharged because they haven't been admitted to stay or reside within the hospital at all. They're just visiting, all right? Okay, so there you go, disjoint rule. So when we use the disjoint rule, we must denote it by this D inside the circle. Any notation that use করতেই হবে to specify the disjoint rule. And just like the completeness constraint in a supertype subtype relationship, either the disjoint rule or the overlap rule, এই দুটার যে কোনো একটা follow করতেই হবে, all right? That's mandatory. Either one of these must be specified. Disjointness constraint এর মধ্যেও এই যে either disjoint rule or overlap rule, one of these must be specified. So disjoint rule হচ্ছে কি আমাকে বলছে যে patient instances cannot be both outpatient and resident patient at the same time. What does the overlap rule say then? Just the opposite. As simple as that. That the instances of a supertype can belong to more than one subtypes. All right? Here, for example, definitely a part instance could exist which is only a manufactured part and only a manufactured part. A part instance also could exist which is only a purchased part and only a purchased part. However, there could be such part instances as well which are both manufactured and purchased at the same time. Sometimes they are manufactured, sometimes let's say they are purchased. Right? Let's say for example, suspension recordable. Sometimes the factory manufactures it, in some cases they purchase it, right? And let's say there's another part, let's say the seat. Seatটা maybe হচ্ছে গিয়ে it's always manufactured. Or let's say there's another part, let's say the carrier bag, right? That is always purchased. And let's say there's another part, the brakes. They're sometimes manufactured, sometimes purchased. ঠিক আছে? So এমন কোনো part instance থাকতে পারে যে হচ্ছে গিয়ে সবসময় manufactured, এমন কোনো part instance থাকতে পারে যে সবসময় purchased, আবার এমন কোনো part instance থাকতেই পারে যেটা হচ্ছে গিয়ে which are sometimes manufactured and sometimes purchased. Let's say the factory manufactures it, but it beyond a certain grade or beyond a certain quality, it has to purchase it or import it from outside. Or let's say, for example, it has a certain quota or a certain limit to how many parts it can manufacture. Beyond that, if let's say the demand exceeds the supply, or the demand basically exceeds the number of parts that have been manufactured, then they get it supplied by an external supplier. So basically, overlap rule specifies that a part instance can be both manufactured and purchased. Whether it makes sense here or not, we don't have to decide that. ঠিক আছে? তোমার মনে হতেই পারে যে I will design my data model in such a way that a part instance, if it's manufactured, it's manufactured. It cannot be purchased. If it's purchased, or that is if it's supplied by a supplier, it's not manufactured. Then you use the disjoint rule. করতেই পারো. Once again, remember, at the end of the day, as data analysts or database designers, the decision is in our hands, how we are going to design the database, all right? So, if some of you guys think that overlap rule doesn't make sense here, you might just think that way. In that case, you design it as the disjoint rule. However, know the difference though. Know that if you're going to use the overlap rule, you must use this O inside the circle. The O represents overlap rule. Circle এর ভিতরে O থাকলে, it represents overlap rule. You must use this O inside the circle to represent overlap rule. And when you use overlap rule, it means that a part instance could exist which is both manufactured and purchased at the same time. Right? However, let's talk about another example that has an event rule. এখানে তো disjointness constraint specify করা হয়নি. What do you guys think? What makes sense here? To follow the disjoint rule or the overlap rule here?
By default should be disjoint.
Anyone else? Does everyone agree with Shafai? In this example, should we follow the disjoint rule or the overlap rule?
Disjoint rule.
It's not a complete specialization, so I don't think it will be either of those.
Yeah.
Complete specialization বলতে কিন্তু কোনো কিছু নেই. In completeness constraint, we have either total specialization rule or a partial specialization. Total, complete, yeah, synonyms here. I get it. But একটু আমাদেরকে হচ্ছে গিয়ে terminology নিয়ে হচ্ছে গিয়ে we have to be a little bit pedantic about it. Why? Because I want you guys to train yourselves in such a manner that if you were ever to face a, and you will face a viva, if you were to face a viva, in that case, you don't mess it up, all right? So make sure that you have these terminologies figured out. So yeah, so Wakil, what you're saying is that because this is not following the total specialization rule, or in other words, because it's following the partial specialization rule, it should follow the disjoint rule or the overlap rule? Which one were you saying?
Disjoint.
Here, like you said, the specialization rules does not
Exactly. So exactly, yeah. So don't get that confused, all right? Don't get that confused. Don't create any association between the two at all. Total specialization rule follow করছে নাকি partial specialization rule follow করছে এটার সাথে disjoint rule overlap rule এর সম্পর্ক থাকবে, that's never going to be necessarily the case. So don't create any association. Completeness constraints আলাদা, disjointness constraints আলাদা. The two are separate things. Whether it's following the disjoint rule or the overlap rule has nothing to do with whether it's following the total specialization rule or partial specialization rule. All right? In this
Both
case,
of them are
maybe it makes
exclusive. Specialization and like right, disjoint rule and rule.
once again, get the terminologies right. I know it's difficult at the start, but force yourself to keep that in mind so that practice makes perfect, basically. Yeah. So completeness constraint and disjointness constraint. What I'm saying is these two are separate things. A specific case, I know where you're heading with what you're saying, Wakil. It makes sense. Yeah. যেহেতু এখানের মধ্যে হচ্ছে কি partial specialization rule follow করছে, তার মানে কি? If it's following partial specialization rule, তার মানে কি? There are such vehicle instances which are neither car nor truck, motorcycle. ঠিক আছে? ওখান থেকে maybe you're drawing some association, but don't do that. It will quickly lead to errors, all right? A specific case, somehow it works that partial specialization rule and disjoint rule or something like that, but it won't work. In most cases, in all cases actually, there is no association between the two. Donota alada. When you think about completeness constraint, only think about completeness constraint. When you think about disjointness constraint, only think about disjointness constraint. Donotake, don't mess it up. You will make errors then. এই জিনিসটা করলে ভুল হবে। যখন completeness constraint নিয়ে চিন্তা করবা, তখন চিন্তা করবা কি যে can there be vehicle instances which are neither car nor truck? Can I allow for such vehicle instances to exist which are neither car nor truck? Can we do that? Can there be such vehicle instances?
Yes.
Yes. Not only can there be such vehicle instances, there must be such vehicle instances which are now neither car nor truck. That's the only question you ask. Disjointness constraint নিয়ে আমরা চিন্তাই করব না। Just simply vehicle এর এমন কোন instance কি থাকা লাগবে যে হচ্ছে গিয়ে neither car nor truck. If the answer is yes, it follows partial specialization. And if you see that there simply cannot be any vehicle instance which is neither car nor truck, then it should follow the total specialization rule. You only ask that question. শুধুমাত্র we focus on that. যে super type এর এমন কোন instance থাকতে পারে কিনা which doesn't belong to any of the subtypes. This is the only question. Can the supertype have any instances which does not belong to any subtype or not? That is the only question. If there is such an instance, then it's partial. If not, then it's total specialization. The only question, can the supertype have any such instances which belong to none of the subtypes? That's the only question. But when we move on to the disjointness constraint, in that case, the question we ask is whether the instances of the supertype can belong to more than one subtype simultaneously. Supertype instance gulo, more than one subtype, can they belong to more than one subtypes at the same time? That is the question you answer. Completely different question. All right, separate question. You might sometimes see that, okay, কোনো একটা relation থাকতে পারে, but make sure that you still force yourself to create that distinction. যে আলাদা question, ঠিক আছে? When it comes to disjointness constraint, the only question you need to ask, supertype instance gulo, can they belong to more than one subtypes at the same time? That is the question we ask when we talk about the disjointness constraint. In this case, can such a vehicle instance exist which is both car and truck at the same time, or both motorcycle and truck at the same time? That is the question you need to ask. A car cannot be truck at the same time. A car has number of passengers. It does not have capacity or cap there. Can a car and a truck, can they overlap? Think about that. Can you have such a vehicle instance which is both a car and a truck at the same time, or both a motorcycle and a truck at the same time? Anything like that?
No, miss.
No,
No, it doesn't
No,
make
ma'am.
sense, right? So in this case, it should follow the disjoint rule based on that. Okay. Or হতেই পারে তুমি এমন একটা অর্গানাইজেশনের জন্য কাজ করছো, তারা একটা নতুন প্রোডাক্ট লঞ্চ করবে যেটা হচ্ছে গিয়ে it's a hybrid between a car and a truck. That is, it has number of passengers, capacity, I mean, it can be used as a car and a truck both. All right. Let's just say, ধরো SUV টাইপের কোন একটা কিছু, all right, something like that. So in that case, you could say that okay, আমি এই ক্ষেত্রে overlap rule apply করি। তখন হচ্ছে overlap rule would make sense that some vehicle instances are only car, some vehicle instances are only truck, some vehicle instances are only motorcycle, but কিছু vehicle instances থাকতেই পারে যারা হচ্ছে গিয়ে both car and truck at the same time। ঠিক আছে, হতেই পারে এরকম organization. It will vary from case to case. All right, there is no such thing as one shoe fits all. All right, so it will vary from case to case. If you were to work for such an organization যেখানে তোমার client তোমাকে বলেই দিয়েছে যে এরকম vehicles কিন্তু থাকতে পারে যেখানে হচ্ছে গিয়ে they're both car and truck, or if you're confused, you ask your client maybe, and if you see that there is no possibility of a vehicle instance being both car and truck at the same time, you use the disjoint rule. However, if your client says that okay, there could be such vehicles which are both car and truck at the same time, in that case you use the overlap rule. Remember, overlap rule does not mean that every single vehicle instance must overlap. No, it does not mean that. Overlap je hotei hobe not necessarily. It means that there could be a vehicle instance which is only a car. There could be such a vehicle instance which is only a truck. And there also could be such a vehicle instance which is both. All right. Okay, so because of that, I'm saying don't create any association between the completeness constraint and the disjointness constraint. দুটো আলাদা জিনিস। Okay, always remember to differentiate between the two. Now, finally, subtype discriminators, the last thing that we'll discuss in this specific topic. All right, so sometimes we have subtype discriminators to let us know beforehand within the supertype which subtype it could belong. For example, here, compared to the previous representation of this same case, notice that we have a new attribute within the supertype. Supertype এর মধ্যে একটা নতুন attribute এনেছি, employee type. And no, this doesn't have to be bold. All right, এখানে একটু bold করা আছে just to bring your attention to this. This is not a part of the notation. The subtype does not have to be written in bold. No, it can be written just as a regular attribute. Now, employee type, this value basically tells us which subtype it belongs to. Here, for example, if employee type is H, it would tell us that it's an hourly employee. If employee type is S, it would tell us that it's a salaried employee. If employee type is C, it would tell us that it's a consultant. So এটা আমাদেরকে অনেক সময় হেল্প করে কিভাবে যে এমপ্লয়ি টেবিলটার মধ্যে এই এমপ্লয়ি টাইপটার ভ্যালু দেখেই আমরা বুঝতে পারবো the employee that we're looking for, whether they're an hourly employee, salaried employee, or consultant. All right, so আমাদের হচ্ছে কি আবার আলাদা করে hourly employee table অথবা salaried employee table অথবা consultant এর অ্যাট্রিবিউট গুলো দেখে বা ওখানে গিয়ে এমপ্লয়ি নাম্বারটা খুঁজে বের করে আমার দেখতে হচ্ছে না। Right, let's say for example I'm looking for a certain employee, I won't have to look for them in any of these individual tables. I can directly look in the supertype. Supertype এর মধ্যে আমি just employee type এর ভ্যালু দেখে আমরা বুঝতে পারছি যে which subtype it belongs to. Right?
Especially for the motorcycle example. It's
Yes.
important.
Yes. For the motorcycle example, it's a separate thing, right? Motorcycle example এর ক্ষেত্রে আমরা একটু different way তে জিনিসটা হ্যান্ডেল করব। ঠিক আছে? We'll get to that. This specific notation for the subtype discriminator is for those cases where we have total specialization rule and the disjointness constraint, right? and the disjoint rule, total specialization rule and disjoint rule, right? So in that case, we will use this notation, HSC, standing for hourly employee, salaried employee, and consultant, respectively, right? Why am I saying that? Because if it's the overlap rule, to the overlap rule, কোনো possibility থাকে, if there is the slightest possibility of there being the overlap rule or the supertype subtype relationship following the overlap rule, it creates a bit of complication. Why? Because in that case, what does that mean? A part, for example, if it could be both manufactured and purchased at the same time, then which subtype discriminator means what? We don't know that. Here, for example, H specifically means hourly employee, S salaried employee, C consultant. This works. Why? Because of the disjoint misconstruction. Because it's following the disjoint rule. Because it's following the disjoint rule, that's why it works. Because একজন employee যে hourly employee, সে তো হচ্ছে কি salaried employee বা consultant হবে না, following the disjoint rule. That's what the disjoint rule tells us, right? An employee instance cannot belong to multiple subtypes at the same time. একজন employee যদি hourly employee হয়ে থাকে, সে শুধুমাত্র hourly employee. একজন employee যদি salaried employee হয়, শুধুমাত্র salaried employee. There will be no overlap. So that's why this works. H stands for hourly, S stands for salaried, C for consultant. এখানে যদি overlap থাকতো, this wouldn't work. If there was overlap, in that case, how would you deal with those instances which have an overlap? How would you deal with those part instances which are both manufactured and purchased? কোন একটা specific value assign করলাম, but what if the part instance is both? How do you do that? So that's why we must use a composite attribute for the subtype discriminator. Subtype discriminator, in this case, as you can see, part type here is a composite attribute. Part type, which is our subtype discriminator here, is a composite attribute. Why? Because here, in case of the overlap rule, if the value of the manufactured component attribute is Y, then it means that that specific instance is manufactured. If purchased is N, that is not Y basically, then it means that it's not purchased and only manufactured. However, because we've made it a composite attribute, we have the option of representing those instances as well, which are both manufactured and purchased. যদি শুধুমাত্র ম্যানুফ্যাকচার্ড হয়, তাহলে ম্যানুফ্যাকচার্ড এর ভ্যালু y হবে, পারচেজড এর ভ্যালু n হবে। যদি শুধুমাত্র পারচেজড হয়, তাহলে পারচেজড এর ভ্যালু y হবে, ম্যানুফ্যাকচার্ড এর ভ্যালু n হবে। However, if a part is both manufactured and purchased at the same time, then manufactured will be y, purchased will be y as well. Okay.
Ma'am.
Yes.
Why can't we use a multi-valued attribute here?
Why do we need to use a multi-valued attribute? Do we need to use a
I mean,
multi-valued attribute here? Part type would have multiple values then.
I mean, then I can just, if it is both manufactured and purchased, then I can just write M, P. And then if it's just manufactured, just M.
But aren't you losing structure there? Multi-valued attribute এর ক্ষেত্রে তো হচ্ছে কি তুমি define করছো just the fact that there will be multiple values, that's all. But the fact that there will be only two components, a manufactured or purchased ছাড়া অন্য কোনো অপশন নাই ভ্যালু বসানো, এটা কি স্পেসিফাই করতে পারছো?
Oh, so it's just the specifications.
So think about it. Think about what you discussed. Think about it. That's how we learn, right? যে multi-valued attribute যদি আমরা এখানে ইউজ করতাম, তুমি যেটা বলছো হ্যাঁ যে multi-valued করলাম, এটার মাল্টিপল ভ্যালুস থাকতে পারে, যে যখন ম্যানুফ্যাকচার্ড হবে শুধুমাত্র m রেখে দিব ভ্যালু, যখন পারচেজ শুধুমাত্র p, যখন both manufactured and purchased I will do m, p. That's what you're saying, right?
Yeah.
So it's more like that you are leaving more options open. ঠিক আছে? And when you do that, there's more room for error or more room for misunderstanding. The purpose of drawing this ERD is to communicate our data model or our idea to the next person in the line. তাই না? যে আমার টিমে নেক্সট যে কাজগুলো করবে সে যাতে আমার ডিজাইনটা বুঝতে পারে, এটাই তো পারপাস ERD। যে হচ্ছে গিয়ে লেটস সে ফর এক্সাম্পল কোডগুলো লিখবে, লেটস সে ঠিক আছে, যে হচ্ছে কি ডাটাবেসটা ক্রিয়েট করবে, সে আমার ইআরডিটা দেখে বুঝবে যে কোন জায়গায় কি কাজ করতে হবে। ঠিক আছে, এখানে যদি তুমি শুধুমাত্র মাল্টি ভ্যালিউড রাখো, instead of making it composite as it's shown, if you did part type is multi-valued, that's all. How much information does that give and how much information does this give? যদি এটাকে multi-valued করো, right, in that case it doesn't give out enough information. Multi-valued, okay, fine, but how many values? What do the values represent? M কি represent করে, P কি represent করে, এই জিনিসগুলো তো স্পেসিফাই করতে পারছি না, so we are losing structure. All right, here very specific, it's clearer, it's concise, the idea it's clearly transferred here. The part type subtype discriminator, it can have any one of two values or both, manufactured, purchased. All right, also remember that subtype supertype discriminator these parts are also a part of the notation, যে এই যে ভ্যালু গুলো কিন্তু এখানে লেবেল হিসেবে দিয়ে দিতে হবে, HSC এই ভ্যালু গুলো আমি লেবেল হিসেবে দিয়ে দিচ্ছি। Similarly here as well, manufactured question mark is equal to y, then there should also be a /n, যে whether the value is y or n, whether the value is y or n. So এই জায়গাটা হচ্ছে কি the idea is clearly communicated. All right, that's the reason subtype discriminator, when it's following the overlap rule, you must model it as a composite attribute. That's the notation we follow. Subtype discriminators, when it's following the overlap rule, must be modeled as a composite attribute. Okay.
Ma'am, another question.
Yes.
Yes. Is there any specific reason that it is written like manufactured question mark, purchased question mark, or is it just personal preference? Like just for
No, it's not a part of the notation. It's not a part of the notation. It's just to make more sense to you. That is it manufactured question mark, yeah, y or n. Is it purchased, y or n.
Like I was thinking it's a Boolean type, so
no, it's not a Boolean type. It's not a Boolean type. The question mark is not a part of the notation. It's just the name to make is written that way to make more sense to us. All right, and even when you denote a subtype discriminator, you don't have to use a question mark. Question mark use করতেই হবে এমন কোনো কিছু না. All right, so you could have just named it manufactured and purchased without the question mark at all. However, this is still part of the notation. Equals y/n is equal to y/n. These things are part of the notation. All right, any questions so far?
So ma'am, this manufacture like question mark equals y, that is part of the notation.
Yeah, that's right. Depends on the name. Manufactured question mark এই যে question markটা কিন্তু একটা mandatory part না, এটা আমি বলতে পারি যাচ্ছি, ঠিক আছে?
Whatever I give in the line as well.
Yeah, exactly. এখানে যদি manufactured এর জায়গায় তুমি যদি created ও দিতা, ঠিক আছে, without any question mark, এখানে তুমি created বসাতা without any question mark. All right, so that's the thing. The rule is that you must model it as a composite attribute, and obviously the component names must make sense as well. এখানে manufactured obviously because subtype এর নামটাও manufactured, purchased because subtype entity নাম হচ্ছে এখানে purchased, so it should make sense. And also here, whatever name you have used here, regardless of the question mark, whatever name you have used here, you just simply put that name here with or without the question mark. Question mark যদি নামে থাকে তাহলে এখানে থাকবে, নামে না থাকলে এখানেও থাকবে, and equals y/n এভাবে থাকবে, ঠিক আছে? Same goes here for subtype discriminators when it's the disjoint rule, HSC, whichever the value is, you assign that. All right, and obviously I hope it makes sense that H because it's hourly employee, S because starts with S, salaried employee, C because consultant starts with C. All right, that. Now subtype discriminators are not mandatory in exams. All right, যে এক্সামে যদি subtype discriminator কথা হিন্ট করা না থাকে in the business rules, it's not mandatory that you need to draw the subtype discriminator. Right, so আমি যখন ERD questionটা let's say case studyটা যখন পড়বো আমরা, তখন যদি দেখি যে subtype discriminator হিন্ট দেয়া আছে, ধরো কোনো এক জায়গায় হিন্ট করে দেয়া আছে যে এটার বেসিসে আমরা বুঝতে পারি যে কোন subtype, somehow there is a hint given there, then you go ahead and model that specific attribute as a subtype discriminator. যদি হিন্ট না দেয়া থাকে, don't bother. you won't even have the time. ঠিক আছে? Don't bother with that if there is no hint, like if there is no such hint. However, when you move on to the next steps, অন্যান্য টাইপের কোয়েশ্চেনে সাবটাইপ ডিসক্রিমিনেটর যদি আমার দিয়ে দেয়া থাকে কোয়েশ্চেনে, তখন হচ্ছে কি ওই অনুযায়ী আমাকে মডেল করতে হবে। ঠিক আছে? Alright. So to give you a little bit of idea of the hierarchy that we could have, supertype subtype hierarchy, you could have multiple supertype subtypes in a single ERD, by the way. And the hierarchy, how we place them from top to bottom. All right, the person from where it all started. All right, from the person, basically the supertype from who everyone inherits, is placed at the top position, right at the top. Okay, and then we go one by one. After person, we've got, as you can see, employee, alumnus, student, and then from employee, we've got faculty, staff, student, we've got graduate student, undergrad student, and so on. So hierarchy top to bottom. The entity from which everyone else inherits is right at the top. And then you go one by one. Step by step, you go from top to bottom. Okay, any questions so far? Okay, in that case, I would like to ask some questions. Krishanu Kori Sporsho, can you hear me? Krishanu, can you hear me? Krishanu, are you there?
Hello, hello, ma'am.
Yes, hello, Krishanu. Nice to meet
Hello.
you. How are you?
Yes, ma'am. I'm fine, ma'am. How are you, miss?
Okay, I'm doing all right so far. Thank you very much for asking. Can you please tell me, Krishanu, here, what is the completeness constraint? What specific rule is applied based on the completeness constraint in this specific supertype subtype relationship? কোন completeness constraint এখানে apply করা হচ্ছে? Can you please tell me that, Krishanu? Here, between student, graduate student, and undergrad student, towards the bottom right corner, the completeness constraint that's been applied here, which rule by the completeness constraint are we applying here?
I don't know, ma'am. পারছি না।
একটু lecture attention দিতে হবে। Talked about this quite a lot in details, all right? I'm not sure if you were there or not. Maybe you were paying attention, maybe it didn't make sense. কোনো একটা জায়গায় যদি question থাকে আমাদের, we have to ask those questions, all right? I'm pretty sure that I'm going slow as it is. I remember going quite faster last semester. So at any point, if you want me to slow down even further, that's also right. And if you don't want to ask questions now, feel free to ask questions later on. All right? Or a lecture recording shooting, you can ask questions later on as well. But make sure that you understand these things. Now, here, anyone else care to explain? Come again, what rule are we following here?
Disjoint rule.
Disjoint.
Disjointness is D.
Completeness constraint করতে গেলে like total specialization.
Total specialization rule, that's right. The rule that we're applying here, Krishanu, is the total specialization rule by the completeness constraint. Completeness constraint অনুযায়ী আমরা total specialization rule apply করছি। Total specialization rule apply করছি এটা আমরা কিভাবে বুঝতে পারি?
Double line.
Double line, that's right. So total specialization rule follow করছি, এখানে double line আছে আমরা দেখতে পাচ্ছি। From the student entity, there are double lines here connected to the circle that we see here. Right? So it's following the total specialization rule. Right, and also by the disjointness constraints following the disjoint rule. Disjointness constraint under it, it's following the disjoint rule. Completeness constraint under it's following the total specialization rule. Disjointness constraint under it's following the disjoint rule. So overall, this supertype subtype relationship is following the total specialization rule and the disjoint rule. If you are asked what constraints are being applied here, it's following the total specialization rule and the disjoint rule. Okay. All right. Okay, so similarly, the others, as you can see here, between person and employee, alumnus, student, there's again a supertype subtype relationship, and in that case, which rules are it following?
Overlapping.
Overlap rule. Is that all?
And total specialization.
That's right. Overlap rule and total specialization. What about employee, faculty, staff?
Partial specialization rule and disjoint constant.
That's disjointness constraint. That's a constraint. I'm asking about the rule.
Disjoint.
Disjoint rule.
There, that's right. Very good. So it's the partial specialization rule and the disjoint rule between employee, faculty, and staff. All right, that's all. Let's take a quick break. Small breather. We'll reconvene at 4 in the other session. All right. So I'll see you guys at 4, hopefully. And please.